All right, today we want to talk about solving equations and just an introduction to what an equation is and how we solve them. An equation basically has two sides and an equal sign. And what the equation is basically telling us is that the two sides are in fact equal to each other. And what we're trying to find is what value or values of the variable make this a true statement. So for instance, if we consider this equation is a little different. It's saying that x plus 1 is equal to x plus 1. Now when we're talking about equations, I always talk about a balanced scale. And ignore that top equation. But what we're looking for is on this side I have an x and a plus 1. On that side I also have an x plus 1. Now you'll see that the two sides are equal. Now consider for a moment, what could we take and replace x with and still make this a true statement? So in other words, if I was just to get rid of these x's, and I was to replace each x with a 1, is that true? Well, yeah, that's true. But what happens if I replaced it with a 2? Well, that's also true. And if I replaced it with 3 blocks instead of 2 blocks, that's also true. This is a very different case. This is what we call an identity. And in the case of an identity, both sides of the equation is exactly the same. And when that happens, what we say is the solution for this identity is all real numbers. Now that's just a fancy way of saying any number will work and make this a true statement. So if I replace x with 5, 5 plus 1 is equal to 5 plus 1, well, yes it is. Now if we look at the second equation, in the second equation we have x plus 1 is equal to x. So let's go back to our balance scales here, and I'm just going to clear that off. And I have an x on one side, and on this other side I have an x plus 1. And what I'm trying to do is find what number could I replace x with so that, now we have a slight problem, these sides aren't equal, are they? And think for a moment. I want to take a number as such that when I take that number and add 1 to it, it's the same as the number. Now, if you think about that for a minute, there's no number that will satisfy that condition. Because whenever I take a number and add 1 to it, it doesn't stay the same. So what you'll see in this case, we get something very different again. In this case, this is not called identity. This is an equation that there's no number that will satisfy this condition. So we're going to say there's no solution to this. Now what I find is that when you get deeper into the chapter, what you'll find is often students get into what I call a routine. They know how to solve an equation, so they just go ahead and they follow these steps, and they forget what happens here. One of the best explanations I heard of this is one of my students who said to me, I know when this happens, we run out of variables. So if we were going to try to solve that equation, what's going to happen? You're going to run out of variables. And the same thing with this one. And we revisit that a little later in the chapter. Now in this equation, this one's called a conditional equation. And what a conditional equation means is there is a solution to this. And often there's only one number that will solve it. And in grade 9, we usually have one number that will solve it. The only exception to that is the identity equation that we saw in the first case. But in grade 9, we usually have a single number that will be the solution to our equation. So let's go back to our balance scales and let's clear this off. And we see we have this equation, 3x plus 2 is equal to 5. So if I was to model that, I'd have 3 x's on this side and plus 2 1's. And over here I'd have 5 1's, 1, 2, 3, 4, 5. And so what we're trying to do is find out what value can I replace x with and make this a true statement. Now you might be able to solve that even by looking at it, but we want to talk about a procedure. What we want to do is try to get the x all by itself on one side of the balance scale here. Now how do we do that? Well, I always talk about undoing. If you remember when we were doing our order of operations, there was a certain order that we did the operations in. When we're undoing or solving an equation, we're trying to get the variable all by itself. So we undo. So if I look, you notice that there's 2 on each side. So what I'm going to do is I'm going to take this and I'm going to subtract 2 from both sides of the equation. Okay. Well, you see if I do that, notice both sides, the 2 is taken off of, and so now instead of having 3x plus 2, I just have 3x. And instead of having 5 on the one side, I just have 3. Now, if 3x is equal to 3, then it makes sense to me that 1x is equal to 1. And how I would get that is I'm going to divide both sides by 3. And when I do that, notice now I get x is equal to 1. So whenever we're talking about equations, I want you to think about the balance scale. Now, how are we going to write that out? Well, the way I would want you to write that out is I'm undoing. So how do I get rid of what's the inverse operation, or opposite, often we call it an opposite operation of adding 2? Well, the opposite is subtracting 2. So whatever I do to one side of an equation, I must do to the other. So if I take 2 away from the left-hand side, I have to take 2 away from the right-hand side, and I'll get 3x is equal to 3. So now, since it's 3 times x, the opposite of timesing is dividing. So I'm going to divide both sides by 3, and I'm going to get x is equal to 1. Now, the big thing to remember with equations is this. Whatever you do to one side, you must do to the other. And this is not only true in Math 9, but it's true all the way through high school mathematics. Okay, so this is a big thing to remember. Let's try another one. Now, when I look at this side, notice the x is on the other side of the equation. Now, for some students, that bothers them, and some teachers insist that they move it over. You don't have to. You just have to work on that side that has the x. So I have 7 is equal to, on one side I have a 7, and on the other side I have 2x, and then I subtract 5. So I'm going to start by getting rid of that subtraction of 5. So the opposite of subtracting 5 is adding 5. And remember, if I add 5 to the right-hand side, I have to add 5 over here. So I'll get 12 on the left-hand side is equal to 2x. Now, I don't want to know what 2x is. I want to know what 1x is. So 2 times x, the opposite of timesing is dividing. So I divide by 2, and I'll get 6 is equal to x. And that's my solution. That's the value that if I plug it in here, 2 times 6 minus 5, I will get 7. So 2 times 6 is 12, minus 5, yep, that's 7. All right, now let's try this one. This one often bothers students because they see the fraction. But I know you folks are very good with fractions. And the way that I would read this is I would read this as x divided by 3, and then I add 2 to it. So I'm going to start by getting rid of that addition of 2. So I'm going to subtract 2 from both sides. And I'll get x divided by 3 is equal to negative 4 minus 2 is negative 6. Now the opposite of dividing by 3 is multiplying by 3. So I'm going to multiply both sides of this by 3. Now remember, with a fraction, think of that as 3 over 1. The 3's will divide out, and I'll just get 1x is equal to negative 18. Now, how am I going to remember what to undo first? Well, remember our order of operations. When you were doing order of operations, we started off and we did brackets, and we did our exponents, and then we did multiplication and division in the order they appeared from left to right, and then addition and subtraction, again in the order they appeared from left to right. When we are solving, so when we're doing our order of operations, we use that order. When we're solving, we undo. I talk about undoing. And so we reverse that order of operations. We're always going to start by undoing the addition and subtraction, and then the multiplication and division. So that's a basic introduction to solving equations.